My wife is a math teacher. She was a math teacher of the year here in Ohio a couple of years ago, and I always like to talk to her about how she became interested in math. Because I'll be perfectly honest, I may have like a little bit of an aptitude for math, but I never got sparked. It was never a thing that I said, "Oh man, I like math." I like puzzles and things. And so I probably did get that spark, but I never sort of combined it into this understanding that math might be a pathway. So I'm hoping that the three of you could talk a little bit to us about where you got that spark and when in your life you got really excited and interested about math. Zarek?
Sure, I'll jump in really quickly here. So I think back in childhood, I mean, I had a really wide diversity of interests. I was interested in weather and meteorology, right? There's a lot of data there. I wanted to work and design theme parks. My dad always had the crazy stock channel, right? Like the financial news on. And so there's I was always tangential to things that had a lot of really heavy data involvement. But really, I think where did the spark start for data science or leveraging data in particular? The other thing is, my childhood was not all that recent, and I was rather recently a student in university and in the high school trajectory. And my first statistics class was junior year of college. And I took one elective that was on the foundations of data science and data construction right before graduating, and that was it. Everything else since then was self-taught. And when I got into the real world and I started doing economics research and doing work at the policy level, I started realizing how quickly how important data is to a variety of contexts and a variety of careers and a variety of just applied work that people have to do in real life, right? Even in research and academic context. And so I think I come at this work almost from a personal grievance as well as a spark, right? Of feeling like I didn't get those opportunities early enough, and I had every privilege and educational trajectory. And I went to a great, I went to University of Chicago, great higher ed institution, right? So many opportunities, and yet these really critical real world technology based skills that are so important today for a variety of disciplines, I felt came way too late. And that was the same for a lot of my classmates, right? A lot of my colleagues. And so I think that's kind of the fire that burns for my work at my end.
Hollylynne, was your experience similar, or how did you end up in this work?
So I mean, I think I always had a good aptitude for math, and I decided in college to become a math teacher. But my love for data, which I think is very different than mathematics, and statistics, really actually came during graduate school when I was working with some elementary students, and an elementary teacher asked me to develop a lesson using some data and probability with first graders. And I was like, what? Okay, let me think about that. And it was through the curiosity and excitement that those first graders had with the particular, I'm not going to get into the particular kind of lessons that I was doing with them, that really got me very interested in the cognition behind how one actually thinks about all these ideas. And it propelled me actually into designing my own software tools and really trying to design playful environments for kids to actually be able to experience data in really playful and curious ways. And then as my research continued on, I fell in love with the idea of thinking about data science for not only for my research understandings in the data that I was collecting for my research, but also as an object of what I wanted to develop in curricula for students to actually learn. And so it became a primary object for both my research and my teaching.
That makes a lot of sense. We are going to dig a little bit into the difference between math and data science here in just a moment, so I appreciate you bringing that up. But before we do that, Dr. Clegg, how about you? Where did this journey begin for you?
I would say probably in middle school. So I always, I mean, if you think about there was, for me, and maybe in the early grades, there was always this sort of continuum. You were either an English person or you're a math person, right? Like that was how I looked at it. And I always saw myself much more sort of in the math camp. That was just what I enjoyed more. And in middle school, I got an opportunity to participate actually at Hollylynne's Institute at NC State, the Math and Science Education Network pre-college program. And so I always liked math, but I always was also a very social person. So I always wanted to be with my friends and be hanging out and things like that. And with the pre-college program, I always say that was where I learned that, STEM and doing and engaging in my academics that way, right? Like doing the math and building bridges and, things like that, just STEM in general, right? Could be actually cool because there were people there, my friends were in those classes, there were cute guys in those classes, right? Like I was you know what I mean, I was always like really socially engaged, but then also really academically engaged. And so I think that was where it sort of all got stirred up for me. But we'll talk more about the data science part later.
I appreciate that. So Dr. Lee, you mentioned this difference, and I was talking to somebody the other day about the difference, and I said, and this is probably a poor analogy, but you can tell me. I said it's kind of like asking a programmer, when did you get excited in spreadsheets? Like they're definitely related. They live in the same space, and yes, that programmer probably does know how to use spreadsheets really well, but it's not the same thing. So for those of us who aren't data science experts, could you talk to us a little bit about sort of the discrete differences between math in general, the big umbrella math, and data science in particular?
So I think one of the key differences is reasoning about uncertainty. And so in data science, you have to really, you have to come at things from from the very get-go of thinking about measurement is imprecise. The data comes from the fact that we have measured something about somebody, something, and that measurement is imprecise, that what we do with that data and the decisions that we make with that data is imprecise, and that there is variability in there. And in mathematics, at least in pure mathematics, it is very logical. You can use both deductive and inductive reasoning. You can certainly use those both in data science as well, particularly thinking about some of the techniques that you use behind it. But in mathematics, it's much more about logical reasoning, proof, and certainty in the solutions that you have. There may be different paths to get there, but the solution is one. And in data science, it's not. And so I think that's one of the key differences. And I'll let Zarek and Tammy add in.
Yeah, Tammy.
Yeah, so I guess I want to chime in there, like maybe to just think about it, ask it. Maybe it's more of a question that I have that I'm like exploring. So as we think about athletes and how athletes do data science in their day-to-day work, there's a theme to me that I noticed, and I guess I'd like to get you guys' thoughts on this. We talk about math and data science. Can data science ever not be math, right? So a lot of times when we look at what the athletes are doing, some of the complex reasoning that they're doing is around video data. And so they look at all kinds of data on their play, their opponent's play, and they're figuring out like what those patterns are and using that to make game time decisions in the moment. And in some ways, it feels like it's a big data decision because you've got all this video data and all this sort of information about your opponents and about yourselves, but it doesn't really jive all that much with math. So I guess I love your thoughts on like, is that data science?
So I want to jump into the thing. So I had an NSF project a couple of years ago that was about bringing community-focused CS experiences to young people in different regions. And one of the ones that was developed that I thought was really cool, and I'm curious what you all sort of think about this explanation, is we had a group in the Cleveland area that was interested in data science in particular. And so they partnered with the local science center And the Science Center gave them access to their massive data set of customer satisfaction, of attendee satisfaction, of dwell time, of exhibits that got skipped, of exhibits that had lines, and customer satisfaction surveys, and all of these things. And they showed the students how they collected all that data, and then the students had to analyze the data and make recommendations for exhibits to remove or expand or add. And the center actually was going to make changes based on that. COVID kind of torpedoed everything. But they were working with a data science professor from Case Western Reserve University who told the students that data science is like 10% math and 90% storytelling. And I thought that was a really interesting way of explaining it. And I'm sure it's reductive. But I'm curious, Zarek, if you could talk a little bit, does that jive with you? Is there more to data science than just the formulas? Does it lean into storytelling?
Yeah, I think this is such a good question. I mean, in storytelling and visualization and communication, right, and the way in which you could argue with, you can communicate with, you can write about data to others is so critical. And I think those are some of the foundational skills we want to build in K-12 that are relevant to any student, any career, any life pathway. Right, so I think that those pieces are really important. Emmanuel Schanzer at Bootstrap at Brown University has a really great definition of data science, and he talks about this in the framework of 4 ingredients. So there's math and statistics, there's computer programming and technology, there's domain knowledge, right? So it's relevant to sports analytics, or it's relevant to social studies or civics issues. And then finally, there's data ethics, right? And thinking about, are we using data ethically? Are we using this in a way that helps, social betterment? Are we paying attention to data privacy or monetization or some of those issues? To get back to the math question, I think there are also, putting percentages on it is hard, right? And I think that we can articulate different data science experiences in the existing K-12 subjects and change the ratios, right? So mathematics, it might be 90% math and 10% other things, or 70% math and 30% technology, and maybe there's another 5% or 10% on some of these other applications, right? And it depends on the K-12 subject that you're working within. And I think in data science, you need y equals mx plus b to do linear regression, right? And there's even you need some conceptual calculus to think about optimization problems. You don't need 2 years of hand deriving or hand calculating derivatives and integrals, but you do need a little bit of conceptual background when you get into the most advanced levels in college to think about how calculus and data science intersect to do some of that optimization work. And so I think the answer is it depends, right? And I think our goals, at least in data science, for everyone, is to support all these initiatives, right? And take a Big 10 approach and think about what can engage students in learning and get them excited about doing work with data and get them into ramps, into technology education, or into CS education, or into using data to help them, make decisions in their lives.
That's really exciting, I think. And I know that, Zarek, you talked a little bit about the Data Science for Everyone movement. And I believe, if I've got this right, that as of last month, there's more than, you've convened more than 500 data science enthusiasts of all stripes to think together about how we can collaborate to build world-class data science opportunities for all students. Can you tell us a little more about that NAS workshop, if you will?
Yeah, no, I'd love to. And Hollylynne and Tammy should also add in here, because we were all in the planning committee together to help put this workshop together that was hosted by the National Academies of Sciences. It was in Washington, D.C. We both had in-person attendees and also virtual folks. And I think, as Hollylynne mentioned, this really was a capstone of several years of work in data science education in K-12, and an even longer history of research and statistics education and computer science education, right, related disciplines that fed into this convening that we had. But it was a great way to sort of take stock of what's happened to date, right, and take stock of this new momentum and energy that we have around the term data science and how we can use that energy to infuse these experiences in K-12. So a couple quick takeaways, because we had panels on a number of topics, from teacher PD to learning from practice to thinking about tools and technology in the space. I think a cross-cutting theme across the workshop was student enthusiasm for this stuff is through the roof. You don't have to prove to students that these skills matter, because the students know it better than anyone else. I also think that because data science allows so much topic relevance to kids, right? So you can switch out data sets on things that they care about, whether it's like music, and you can look at music trends on Billboard, right? And Spotify trends, or you can look at sports analytics, right? And your favorite sports team, and look at NBA scores. You could look at dance, right? And like art trends. There's just so much flexibility because you can build relevance through the topic of choice and the data that's underneath. So students, because of that, are moving really fast through the content. We heard experiences from educators where students are getting through the courses faster than they anticipated because the intrinsic motivation is so high. I think we also saw examples where students are learning about their own communities with data. I had an example of a teacher in Sonoma County in California that was raised, the community was devastated by wildfires. Students looked at used ArcGIS and looked at geospatial data of wildfire risks, and then did a presentation, put it all together in a deck, brought it to the state legislators. The state legislators in California were so impressed by the student presentation that they then passed a resolution on climate risks in California, right? And so that's like a beautiful example of how these experiences can like lead to community involvement that's really strong. And then, finally, I think we saw the demand is outpacing the supply of curricula that exists. So students are asking for more opportunities and more courses in these fields. I had a math teacher tell me that, after 20 years of teaching mathematics, when they introduced a data science course, they had students asking them for internships in a math context, and that's never happened to them before. And that was a really exciting story to show that there's like so much energy around this, right? So now I think what we have to do is take stock of the research, figure out what else we have to do to improve these practices, improve our curricular interventions, and also make sure that this isn't just the high school mathematics thing, but this is infused in middle school and elementary. It's infused in other subjects. Right? I think there's a lot of work there to think about how we can increase participation and get a variety of students involved in this work and build ramps to more data exploration.
Yeah, I want to jump in there that two things that Zarek was just saying. So first of all, I mean, you all are here as part of the STEM ecosystems. I mean, data science and doing data is one of those major like connectors in STEM. And it goes back to one of the other major differences between math and data science. Data science is about the context. It's about solving a problem. It's about the data comes from somewhere. You can do math without a context, and sometimes you actually want to abstract out of the context as quickly as possible to get at that underlying generalizability. You should never walk away from the context and the connections in your understanding about the context in data science. It should always be there, and you have to continually be thinking about the decisions you make with data related to your understanding of that phenomena.
Yes, and I'll jump in too. I think one of the things that stood out to me.
Quick water break, Holly. There you go.
Yeah. I got my tea over here too. One of the things that stood out to me, I guess maybe in us talking, was also thinking about how data science is really transforming like what we do in the classroom and how the classroom works, but then also sort of on larger scales. So, one example that Rafi Santo gave in his talk was how they were working with teachers from different subject domains. So I think they had like a social studies teacher and maybe some English teachers and things like that. And they were helping them to do data science in their classrooms. And one of the things that stood out to me was that, I think the approach kind of, the teachers saw themselves as sort of not the experts, right? But that this was something additional they had to put into their classrooms. But when I think about data science and what we talked about as, how it has these broad sort of connections to all these different topics, really, I think that there needs to be a range of expertise, right, that we think about in terms of data science. So maybe the social studies teacher may not be the person that is going to be talking about how to do the advanced calculations in data science, but the social studies teacher probably knows a whole lot about how decisions are being made with data science and what we need to, what we need to teach our kids about making sure that that data science is done equitably and in just ways and helping them to be more critical about their data. And so then I also think about sort of the larger scale that really came out in the conference as well. So thinking about larger scale changes that are needed in K-12 with data science. So people were talking about how it's kind of hard to center data science, right, in the sort of grand sort of infrastructure of education, because it's so focused on calculus. And so like until that changes sort of in these higher levels, right, then actually making it so that data science is really foregrounded throughout the educational system is, is going to be a challenge. So that was one thing that stood out to me.
We won't get into this debate right now because we don't have time, and maybe you just all agree with me, but I got convinced 15 years ago that our math system of everything from preschool on really focusing on a pathway towards calculus should be changed to be a pathway towards statistics and data science. Calculus is important. It's really critical for some people, but everybody can use a basic understanding of data science and statistics, no matter what your job is. It's useful in every job and career path. All right, Hollylynne, we understand that you had a really key role in this work too, from what you talked about, but in particular with convening the teacher training panel. And while that panel emphasized that data science can help re-engage students in an otherwise digital world full of classroom distractions, teachers also need to feel confident and empowered to bring these experiences to the classroom. So you had this panel, you convened this panel. Can you talk to us a little bit about what you learned? That's always the most interesting thing to me. You know, the panels end at conferences and everybody rushes the panelists. I always rush the moderator because the moderator, A, doesn't have the line, B, knows all the panelists, and C, always has really good insights into what they learned through convening this group. So can you talk to us a little bit about what you learned?
Sure. Thank you. And hopefully my cough is going to stay away. But I mean, I think one of the things is that, so throughout first of all, before we got to the panel was the very last session of the 2 days. And throughout all the other sessions, I don't think there was a session where the importance of teachers didn't come up somehow, some way, and the role that the teachers are going to play in making this happen. And so with teacher preparation, we have to simultaneously think about both of the workforce of teachers right now that may be new to their career or may have been there 20 to 30 years, and how are we gonna help them think about ways, and I'm going to not just talk about math teachers, I'm going to talk about all teachers in across the subject areas. How are they going to infuse more data into their teaching so that they can the students have that opportunity? But then at the same time, we have to tackle the pre-service problem. So we have to fix the pipeline so that our teachers coming in are better prepared. And that also means not just teacher pedagogy courses, but the kinds of college content courses that they are getting opportunities to take when they're in their undergraduate. So we have to do both of those at the same time. But there's then we've got to so not only do teachers need training, but you've got to think about the faculty at universities who may have been there 20, 30, 40, 50 years. All right. And how have they been teaching? And we've got to address the faculty professional development at the university level as well. So I'm going to pick on my colleagues in math teacher education. Many of them are math teacher educators, and they study the teaching and learning of algebra and the teaching and learning of geometry. And so when they're teaching their methods courses, they pay a lot of attention to the teaching of algebra, the teaching of geometry, the teaching of calculus, because that's what they specialize in. And so they're just as guilty as teachers out in schools of putting aside any kind of statistics or data science in favor of other topics. And I think one of the things that we've got to really think about is that all of this happens within very difficult systems to change. So not only do we have systems within the public school of like who gets assigned to teach these courses, how much seniority do you have to have in order to get an opportunity to teach a certain course or not? What kind of education do guidance counselors need in order to actually get students into those certain courses? And then at the university level in teacher preparation, there's accreditation, there's licensure issues. I mean, with the computer science for all effort, there's very few states that have licensure for computer science. you know, so are we going to require licensure for data science courses, or if it does fall within the math curriculum, how are we going to actually change licensure so that we could say that all math teachers are able to actually pick up a data science course if it does end up in the math curriculum on a much more wide scale effort. So there's a lot of, you know, a lot of wheels to like get moving in the right direction, and it's definitely a systems problem that we have to have a lot of input into.
Yeah, Zarek?
Yeah, and Hollylynne, I mean, that's where our heads are at all the time, right? And it's 100% thinking about these really big systems level changes. I think if you're a teacher or a ecosystem leader who wants to figure out how to do this next week or how to do this like on Monday, right, and bring this to your classroom Monday, there's also a lot of really easy ways you can start infusing this content in bite-sized ways. And you know, the tools to do it, right? And Jeremy, you started off with the session with the framing of data science as a super scary technical field, right? And all these buzzwords around AI and artificial intelligence and quantum, it goes on and on and on. It is so easy to go grab a spreadsheet or go grab CodeApp, which is a free online tool created by the Concord Consortium. That's a like a classroom specific data analysis tool, open source. Hollylynne, you can probably link it in the chat. Go get a data set that aligns to one of your instructional goals in the next month, right? So you have to teach a lesson on, I don't know, World War II or you know, economic booms and busts, right? In like one of your classes. And you can engage students in the content through looking through the data, summarizing the data, doing like really, you know, basic, you know, summary statistics, and then put together a couple data visuals, right? And what this is about, I think, especially the early grades, is building student confidence. And as a teacher, you should feel like you have the confidence to do those things at the early grades to build that intuition and build those muscles, because that's so important for identity formation, right? And what Tammy, you were saying when you're in middle school, right? And having that spark. I mean, I think creating those foundational experiences to then get to the high school stuff is so important. So yeah, I think you should feel empowered to do this at a number of levels, and that there's a number of on-ramps into this work.
Dr. Clegg, I know that when all these panels were being convened, you convened a panel to focus on partnering in the out of school time arena to bring additional support. I'm a very big believer, and so are all of the ecosystem leads that are on this call or listening later, in that the necessity of reinforcing skills and ideas through out of school time opportunities. Can you tell us a little bit about what the participants in your panel had to say?
Yeah, so it was interesting because some of my panelists on my session, they were in K through 12, but they were really looking at these sort of topics and sort of activities that tend to stem from out of school context, right? So some of them were looking at, you know, how comics could be used, right, to display or for data science, right? Or they were looking at like how data science could be used in museums and, you know, different things like that. And so yeah, I think one of the one of the things was the key sort of points in my session was that like these topics that kids are really interested in, that they're engaged with, right, should be the center of our experiences with data science, or our kids' experiences with data science, whether they're in the classroom or out of the classroom. And I was going to share a story about one of my my research projects that I was thinking about as Zarek and Hollylynne were talking. We created this with some colleagues, and I can link it in the chat too. We created a tool called Body Viz with some of my collaborators, where kids would actually like strap sensors to their chest, and they would we had an e-textile shirt that had all of their upper respiratory organs represented. And when they wore the shirt, the heart would actually light up according to the heart rate, and the lungs would light up according to the breathing rate. And then we had some large screen displays that would actually show them in real time. They could see a line graph. Up to 6 kids could wear sensors at one time, and they could see a line graph of their heart rate in real time. And so the kids would actually do these different like investigations. So they, you know, we'd say, what do you want to explore, right? And so some of them wanted, what happens to your heart rate if you get really scared? What happens to your heart rate if you do jumping jacks? What about if you what if you eat candy, right? Like, how does that affect your heart rate? And so the kids could try all of these different things. But the interesting thing was that a lot of times the things that they wanted to try, like what happens when you're playing football versus basketball to your heart rate, were things that you would do typically outside of the classroom. So they sort of violated some of the norms with space and with objects and things like that, because in elementary school, a lot of kids couldn't eat in the classroom, right? But they wanted to test out eating candy, right? Or they wanted to be in certain spaces in the classroom or do certain things that weren't that sort of weren't the norm for those classroom spaces. And so it really made us think about what are the ways that we need these new collaborations. Could kids collaborate, or could a PE teacher and a data science teacher collaborate, right? So that kids could do some certain parts in the gym, but then certain parts they come back in the classroom to do. Or, you know, and how can out of school activities, things that the kids do at home, be brought into the classroom and back, you know, to facilitate these types of learning experiences.
Tamara, I've got a box of Raspberry Pis sitting over there that I'm always looking for more things to do with, and I know what's next because I want that shirt. I want to wear it just every day, not even to collect the data. I just want it showing what's happening all the time. I want to go to a question from Stefana here in a second, but first, Deb Wilson is asking in the Q&A, why can't I copy and paste from these links and things to the from chat into Word? I don't know. You normally can. That's weird. What I can tell you is that we'll make sure to put all of the links in the follow-up email that you'll get in just a couple of days. So you'll get them there, and we'll look into why you're not able to copy and paste into them this time. So I'm hoping that Stefana, I hope I'm saying your name right. Stefana, are you there with us?
Can you hear me?
I can. Would you mind asking a question
Perfect.
about data science concepts?
Of course. And first of all, thank you, Hollylynne, for addressing this a little bit. And I'm really excited to hear more. So my question is, which data science concepts do you think should be covered at the high school level to prepare students for the current workforce? And so I'd love to hear a little bit more about your take on this.
So
Hollylynne?
first, I think it depends on what you mean by a data science concept. So I think so my initial answer to her, first of all, I apologize because I didn't realize that if I answered it, it was going to actually take her question away. I thought it would start a conversation. But yeah, so I mean, I think when we think about data, you know, that data literacy for everybody, you know, so the basic concepts of data really start with, and I had mentioned this earlier, about the ideas around measurement. I mean, how does data come into existence? Thinking about what you have to do to actually measure. How do you organize data? How do you think about the structure of data? And as kids get older, the structure of data gets bigger and more complicated. And so I think that's a really first key thing. I mean, you can't do data science without data. And so you have to think about kind of what data is, what constitutes data. And data it's not just numbers and categories. I mean, we also have data that is geospatial. We have data that is images. We have data that is text. And so coming to understand what can be constituted as data and what you actually have to do to organize it and process it and structure it in a way that you can then do some analysis with. I think that's the very first kind of core concept. And instead of continuing on a big list, I'll stop there and see if Tammy and Zarek want to add on.
Yeah, I would like to add on. I think another way that we really have to think about data literacy for our youth in general is thinking about not just like how do we prepare them for the workforce, but how do we prepare them for society? How do we prepare them to be data literate citizens? So with that, we need to help them think about the aspects that Hollylynne just talked about, but we also need to help them to think about more critical aspects of data and data literacy, right? So who's collecting data about me, and who's what kind of decisions are they using that data to make? What kind of stories do I want to tell with my data? What access do I have to my data? How is my data affecting my community? So I think we need to really engage our students in thinking about these kinds of things too, and give them ways to have more agency with thinking about like what privacy and security settings, how do they want to manage that? Like how do they want to think about telling stories with their data, and how they can be critical about how data is used and how they can have a voice, sort of like what the story that Zarek shared about the students shared with the legislature.
So I'm going to tackle this question mainly from a tools and technology perspective. But first, the one thing I want to emphasize, I'm going to steal from Hollylynne here in your prior NCTM sessions, is multivariable analysis. So much of especially in mathematics, so much of it is focused on two variables, right? Two-way tables, one-way relationships. The world is multivariable. And there's so much complexity in data and in data science techniques in the modern workforce. And I think getting students to understand that complexity, to be comfortable with it, to know when more variables is good, when more variables is bad, when you need to find different variables you don't necessarily have yet, that like really foundational thinking, I think, is really critical. On the tech, and Hollylynne, please add if I didn't do that justice. on the tech and tools side, I think students come at this from a really different baseline, right? And so it's hard to peg exact grade levels to exact tools. But the way that we've been thinking about this is there's maybe progression in technology in data that students can work through. It can start with these classroom specific tools, the CodeApp Data Classroom. There's a few others out there. The Pirate is another great example of classroom education specific tools that are created for data analysis. Then you can move to spreadsheets, right? These are real world tools that are used in business, a variety of industry applications all the time, Microsoft Excel, Google Sheets, et cetera. And then you can move more the programming intensive languages like R, Python, Tableau. Jupyter Notebooks is a great way to introduce Python code in a really like light touch way. And you can get to those at the sort of the end of high school and get students comfortable with really light touch programming and light touch coding that involves modern data analysis and data science techniques at scale, right? So I think there's a progression of tools that you can think about as students go from the younger grades, the middle to the older grades into college, and to equip them with the technology confidence to allow them to do then their own work or their own exploration online, because there's so many online self-paced resources that students can tap into this to get industry credentials or to get aligned really closely to specific industry needs. And so I think that's another way you can think about the scaffold. It's really important not to forget the societal and critical implications that Tammy spoke to, because I think we want to not just view this as an industry output. Our goal isn't to create thousands of professional data scientists, it's to create data literate citizens.
I think that makes a lot of sense. And in a moment, I'm hoping, because I think this is all related, that the three of you can talk to us real briefly about any calls to action that you might have. But before you do that, I want to get to one more question from our audience. Deb Wilson. Deb, are you there with us?
Yeah, I'm here.
Hi, Deb. Can you ask your question?
Yes, I was wondering, I've been trained with this. I don't know if you can see it or not. It's a National Computational Science Institute, the Introduction to Computational Thinking. Now I'm wondering, because there's a lot of data science connected to this, and this is, I was trained in this probably 8 years ago. So I'm wondering how that relates to the data science we're talking about here.
So if we're thinking about moving into data science and data literacy, we've already got some skills that are at least related. How do these fit together, Hollylynne?
Well, I was just going to say that I think I sort of know the reference that you were saying. If you put it in the chat, I didn't see it, but I do think that a lot of the computational thinking, I mean, there is a lot of data work that happens in computer science and the work in computational thinking, because thinking about how you tell a computer what to do, that algorithmic thinking is incredibly important in working with data. And that goes into thinking about reproducibility in data science. Of you want to be able to reproduce and automate different analysis that you do, and that those take lines of code. that takes some programming. All right, not a whole lot, but a little bit, and so I think that they are incredibly related. And so I think that one of our challenges in the community is to actually make sure that we're learning from all of the work. Like I was mentioning work in statistics education before, there's work in computational thinking that we also need to be drawing upon, and making sure that that we're learning from that as we try to think about this in a coherent way.
Yeah, and I think also that, because I think these skills are so interrelated, right? We did an event on this, on how to connect data science and AI to computer science, computational thinking, and I think that it's hard to parse the terms a little bit because they're related. And the way that I've thought about this, and maybe imperfectly, is that data science experiences or data literacy experiences in K-12 is a great way to articulate computational thinking in a really concrete way for teachers across subjects.
because you're not just telling teachers go code, right? And like go code in history. You can create a data set around a really specific topic that you already want to teach the students about, and then build in the computational skills in the background kind of by stealth, using the data set as the content that drives the lesson forward and already meets your existing instructional goals, right? So I think it's a really concrete way to articulate those principles, but in bite-sized formats.
I mean, it all makes a lot of sense. I'm really excited. I'm excited, frankly, to dig into the work that all of you have been doing and have done. This is a passion. I was telling Zarek and Dr. Clegg the other day that a colleague of mine is really interested in amping up this type of work in the Northeast Ohio region. And I actually know of a handful of other regions around the country that are also very interested in expanding data science and data literacy initiatives without a lot of knowledge on how to make that happen. So I'd like to close real quick with any calls to action that the three of you might have. Dr. Clegg?
So yeah, I think one of the other things I wanted to kind of come back to the question before Deb's question that we were talking about was that another thing that we should really think about in terms of teaching our kids about data science is helping them to see how they already do it, but how they may not call it that. And what are some of the informal techniques and things like that that are used in their families and their neighborhoods and by themselves, right? That we want to draw upon and build upon. So for example, when we talked to the athletes, when we first started doing interviews with them about their data practices on their sports teams, they didn't, when we say, what is data? It's like crickets. But when you say, what about your stats? Or what about film, right? Then they just light up and they go to town and telling you about, all of these data practices that they're doing. So we really have to kind of look for those connections and use the kids' language and the kids' context as well.
Thank you. Zarek?
Okay, so I have two. I have a cheeky one and then a serious one. The self-promotional one is go to the Data Science for Everyone website and look at our resource hub, because we have so many curricula, lesson plans, all the software, et cetera, listed out there and in one place, and how to, as examples, right, of how you can articulate this across a lot of different contexts. The serious one or the motivating one. We've been thinking a lot about in our team of how we can create local partnerships and local communities, local ecosystems right around this work. And I think what we saw at the National Academies Workshop is that we talked a lot about when we were discussing teacher prep, that's been so important to do co-design between teachers, district folks, people in the after school community, parents, right? Like bringing in a wide variety of stakeholders and how we think about creating these data science experiences and then connecting it for students in both formal and informal learning. And so I'd love for the ecosystem leaders to take this challenge on, and let's create data science for everyone local chapters, or maybe they're called local data hubs, or communities of data literacy practice. We can iterate on the name and do some brainstorming there. But I'd love to think about how we can create local working groups and local ecosystems to create really aligned student pathways that are both in and out of school around these experiences, because the field itself is so interdisciplinary. It's connected to civic engagement and careers, right? So how can we make the experiences holistic? And I think there'd be a lot of power there.
I love this idea. Dr. Lee, you want to close us out?
I would just say that, I don't think I can say anything more profound than what Tammy and Zarek have said, but that, just do data yourself and, work with a colleague to kind of think about how you can help get better data into the schools in your area, and, take action at a local level. You would be surprised at how that can grow momentum, and have fun with it.
Well, thank you very much. Thank you, Zarek, Tammy, and Hollylynne for leading the charge in data science and helping us think carefully about action steps we can take to support our students as they prepare for a world that is truly replete with data science. Tomorrow brings another exciting opportunity for us to think together about this rapidly changing and critical field of STEM education. We'll roll out a CHIPS and Science Act briefing book at 1 o'clock Eastern Time tomorrow afternoon. The webinar will give you and all STEM education partners a front row view of the incredible work that Data Science for Everyone, STEM Next, Battelle, SLECOP, and so many others are accomplishing as we work collaboratively to create incredible STEM education opportunities for all students. Come check it out. We'll have not one, but two all-star panels in the house to talk about where we are and where we're headed with help from the CHIPS and Science Act. Lauren's going to drop the link in the chat. We'll hopefully see you all there tomorrow. And if not, we'll see you all next time. Thanks, everyone.
Thanks for hosting, Jeremy.
Thank you.
Yeah,
Yeah,
thank
thank
you.
you, Jeremy.
This was so
This was
much fun.
great.
Thank you.